with the chairman of Komatsu West Africa, and he was telling me how they have used particularly this area of study topic to beat a major competitor, which is Caterpillar, in the business of fleet management and getting contracts in Nigeria. Now, Internet of Things has become virtually the bloodline through which instructions are passed to devices, sensors, switches, in controlling systems and equipment today. The position of the industrial engineer has become that of the ANISA, the person who harness all these controls, devices developed by the electronics engineer, the mechatronics engineers, and everybody, and utilizes them to achieve the best possible maintenance management, fleet management, resource optimization, and even to the extent that today, for scarce resource allocation, this has become something very, very critical, which industrial engineers you can use, some are using to change the story. I'm very glad, and I'm sure that Engineer Idris Oshodi has really prepared a lot for today, because the merely seeing the topic, I know that he's prepared for this interesting topic. It's a discourse. I want you to listen keenly, attentively, take notes, prepare your questions, and I'm sure you're in for a very good time. Not just for good time in your career, in what you do. I'm sure you'll find one thing or the other we can also benefit to develop our own area of work. And I'm sure he is able to deliver it. Thank you very much. Welcome, everyone. Engineer Oshodi, over to you.
Thank you very much, sir, Engineer Olajide, for that opening remark. I believe we are all preparing our notepads and our pens and papers, as the chairman rightly said. Is going to be a discourse, and I believe we are going to have an interesting session. Once again, thank you very much for joining us this evening, and I myself am very much pumped for this session. So moving on, we'll be having a couple of goodwill message from some of our special guests of honor that we have in the environment today with us. I'm not sure Professor Stein is in the room with us yet.
It's been represented by Professor Olufemi Adetunji.
Oh, okay. Because I was wondering that I didn't see in the audience list.
Olufemi Adetunji is representing him.
Okay, thank you very much, sir. So I guess we'll be moving on to the goodwill message from Professor Stein, who is ably represented by Professor Olufemi Adetunji. Thank you very much for joining us tonight, sir. And we are rightly gracious and grateful to have you amongst us. Professor, so we are awaiting your goodwill, sir. Okay, thank you very much, sir.
I'm sorry. Apparently, I was muted initially by the coordinator, so I couldn't unmute myself for some time. Thank you. My name is Olufemi Adetunji from the Department of Industrial and Systems Engineering of the University of Pretoria, South Africa. And I'm also an alumnus of the department, so it's a delight for me to be able to come home every time, like today, to appreciate the good work that the department does, that has been done in many people like me, and that is still doing. I often tell Professor Ladokun that I believe our department in Nigeria, in Ibadan, works under very difficult conditions to still produce the best that could be done. And in spite of that, we keep turning out good products every time. Thank you so much. And congratulations to Professor Ladokun and the team. I'm speaking on behalf of my dean, Professor Van Stein, who is not available now because he's out of the country to attend to another important engagement. So on his behalf, I congratulate you. I thank you for the opportunity you've given him, and by extension, me, to be able to participate in this program today and to thank you and to listen in. And the topic we are listening to today is very apt because it is an area that has had evolution over time, particularly sometime around 1995. We have a standard defined by an association called International Society of Automation in the United States, where they first presented what they call the 5-layer architecture for industrial Internet of Things, double IoT. And I was telling someone that the role of industrial engineers is so important that we are like the binding agency. Because when you see the lower layers that started from the human-machine interface up onto SCADA layer, until you get towards around the enterprise resource planning system, another layer. The layer that seems least understood in that area is the layer usually called the manufacturing execution systems. Before you now have what we have at the top today, where ERP comes, like I said, and then the cloud system. The interesting thing is our layer as industrial engineers is the least understood. And like the chairman has said, this is actually where a lot of binding should come. From those that work with the physical sensors at the bottom, people like electronics engineers, mechatronic engineers, chemical engineers, mechanical engineers, and those that work more with the data system at the top, like sister departments from computer science. So when we listen to lectures like this, that are looking from the strategic perspective, how we integrate all of this to deliver solutions, it's always a very interesting thing. I congratulate the department for bringing this type of lecture to be. I am also going to be listening in attentively to how this has been used in the particular industry that will probably be used as the case study here. And I congratulate the speaker and thank you for preparing the lecture for us. I wish every one of us a beautiful learning experience and a journey of new things as we listen together. Thank you so much for having me, and God bless you all.
Thank you very much, Professor Olufemi from the University of Pretoria, representing Professor Stein. I don't know if it's just me, but this is seeming to be a very interesting session already. I mean, we have our chairman of the day, who is an alumnus of the department, Professor Olufemi as well, an alumnus of the department, representing Professor Stein. And I mean, I just had something very interesting from Professor Olufemi, which is IIoT, Industrial Internet of Things. Honestly speaking, that would be my first time of hearing this. And the way it shows briefly the interconnectedness of systems at the upper layer and at the lower layer, I think would really have an enjoyable session. Yes. So moving on, we'll be going to the next goodwill message from another one of our special guests of honor, from Professor J.A.O. Akintayo. So thank you very much for joining us tonight, Professor Akintayo. It's a pleasure to have you amongst us, sir. Thank you.
Thank you very much for having me. The chairman of this occasion, Engineer Ajibola Olajide, the special guest of honor represented here, the guest speaker, and the head of Department of Industrial and Production Engineering, University of Ibadan. I am delighted to be here. You may wonder I'm Dean of Law. And one may wonder what has law got to do with what we are talking about. Law is about everything. And the interface between law and engineering is well established. Let me commend the head of Department of Industrial and Production Engineering, Professor Victor Ladokun, for this very impactful session. And the idea of alumni meeting to look at critical issues, having intellectual session must be commended. And I think this has, in a way, fulfilled the expectations of founders of university. From a legal perspective, one of the university consists partly of graduates and undergraduates. And what that entails is that the relationship between graduates of a university and the university is a lifelong relationship. It doesn't terminate with completion of degrees and then going into the job market. You, as alumni, you are members of the university. And a program like this puts emphasis on this relationship. This is the 27th alumni lecture, and I'm happy to be part of this experience. From the perspective of an outsider, industrial engineering is perhaps the least known branch of engineering. In secondary school, we interact with students where we have an idea of what civil engineers do, mechanical, electrical. One cannot but be intrigued and be fascinated after due exposure to what industrial engineers are doing. The multidisciplinary nature of the discipline itself, because you do some economics, some sociology, and you bring everything together to ensure that technology is integrated into different operations so that we can have optimization. My association with the department maybe is at two levels. I participate in the teaching of masters in engineering management, and my spouse happened to have taken a second degree from industrial engineering. And at that time, I recall I was doing a work for port productivity. And productivity is a concept that is central to industrial engineering. I had course to use some of our textbooks talking about efficiency, effectiveness, optimization. So I'm very happy with what is happening here today. And I know that our guest lecturer, Engineer Idris Oshodi, is well prepared to enlighten us, especially a novice like me in Internet of Things, and talking about enhancing fleet management with Internet of Things, concentrating on the strategic role of the industrial engineer. I want to commend this initiative, and I also want to encourage us to get in touch with our colleagues who are not on this platform. Education is a lifelong endeavor, and we cannot monetize the value that we derive from this kind of engagement. The last speaker just said where industrial Internet of Things and expression is coming across for the first time, and that's how ideas grow, develop, and we harness our potential to ensure that we improve the way we do things. So I commend the HOD, and I'm looking forward to an interesting evening with us. Thank you very much for this opportunity you have availed me to be a guest of honor. I'm very grateful. Thank you. God bless. Over to you, the moderator, please.
It's like our moderator. Sort of.
Can you check if the moderator can unmute himself so that we are sure
let's
it's
just
not muted?
let him get back.
Yes.
Okay, let's find out why he's not able to unmute himself. Did you change? Okay, let's host make Adeni Sanusi the host. That's another name for Waris.
Oh, yes,
Adeni
yes.
Sanusi, make
Thank you very much, sir. Please, can you hear me now?
Yes, we can hear you.
Oh, okay.
Yes, we
Thank
can
you
hear
very
you,
much.
Waris.
Thank you very much. Apologies. I had a brief internet issue. Right. So I was trying to switch from my mobile to my laptop. So that was a brief disconnect there. Thank you very much, Professor Akintayo. I think before I had my own break in internet connection, one aspect that stuck with me was the relationship Professor Akintayo has had with the department over the years. I know some alumni sessions like this that I've attended myself in the past. Professor Akintayo has been a part of it, and him saying that his wife is even an alumnus of the department. I think that's one interesting and unique thing about our guest speaker for today. So without wasting much time, I'll be going on to the citation of our speaker for today, which will be read by Mrs. Idayat Oshodi. There's a reason why I've held back on saying the name of our speaker, right? Since we began, and the reason I'm almost getting there, right? I mean, Mrs. Idayat Oshodi is also the wife of our guest speaker for today, who is Engineer Idris Oshodi. So please join me in welcoming Mrs. Idayat Oshodi, who will be giving us the citation of the guest speaker. And Mrs. Idayat is also an alumnus of the department. Thank you very much for joining us tonight, ma.
Thank you very much. Thank you. Good evening, everyone. Good evening, sirs. Good evening to the chairman, the special guest, and everyone here. I'd like to share my screen. Give me a minute. All right, please confirm you can see my screen.
Yes,
Yes,
we can
ma,
see
we
your
can.
screen, madam.
We can.
Okay, all right. Thank you, everyone. Standing on existing protocol. Oshodi Idris is an accomplished professional specializing in fleet management, logistics, and journey risk assessment. He holds an MBA in finance from the University of Lagos and a bachelor's degree in industrial and production engineering from the University of Ibadan. Currently, the fleet manager at Sahara Group, Idris oversees a high-value fleet while driving digital transformation and process efficiency within the fleet unit. In his previous roles at Transport Services Limited, TSL, which includes fleet manager and journey risk manager, he was responsible for a fleet of over 800 trucks, 7 major clients in the oil and gas sector, FMCG, mining, construction, and food sector. In these roles, Idris streamlined operations, enhanced HSCK performance, and consistently achieved excellent journey management audit scores from multinationals such as Lafarge and Total. Idris holds a range of certifications, which includes the database administrator and expert installer credentials from Mixed Telematics, truck diagnostics training from Scania West Africa, and ISO 39001 lead implementer and internal auditor certifications from the British Standards Institute. Idris is very passionate about leveraging technology to foster process automation, drive logistics innovation, and achieve operational excellence. He is happily married with children. Thank you very much.
Thank you very much, ma'am. I think that's a very brief and straight to the point citation of our guest speaker. Now moving on to the reason why we are all here tonight, which is to listen to Engineer Idris Oshodi on what is the strategic role of an industrial engineer, particularly when it comes to enhancing fleet management with IoT. For me, I think maybe before I bring our guest speaker to the room tonight,
I mean, he's here with us already. One particular aspect that I'm very, very much looking forward to here is that intersection, and I'm trying to see fleet management on a broader level of supply chain now, right? And I think it will be very, very interesting. One of the previous sessions that we've had here with one of our alumnus in time past looked into using artificial intelligence in improving supply chain, where he showed us some aspect of how we can use Google Cloud to build machine learning models, to improve and forecast demands and things like lead time and orders and so many, many interesting concepts around supply chain. So I believe this would be a very much interesting system. Join me as I welcome engineer Idris Oshodi. Thank you very much for joining us tonight. It's a pleasure seeing your face bright on our screens, and we're really, really glad to have you. You have the floor now. Thank you very much, sir.
So good evening, everyone. Thank you very much for having me, and I'm extremely honored to be here, and I look forward to, like, my lecturers who are here also here. I will also say lecturing also is an avenue for even the person lecturing to also learn, and I'm also sure I'm also here to learn as well. And like, once again, I'm extremely honored to be here. So I'll go into it. Output code duly observed. I'll go into it shortly. Is kindly confirm you can see my screen?
Very much, sir. We can.
Okay. Okay, so we're starting with just an overview of what fleet management is, and part of the key components of fleet. So fleet management, basically, it's a coordination, supervision of vehicles, fleets. It might be a mixture of fleets, it might be a mixture of heavy goods vehicles like trucks, can be a mixture of with vehicles like light vehicles like your utility vehicles, and even motorbikes. So it's a fleet of vehicles basically that are basically used for a specific purpose, usually operations. So fleet department in some companies, basically you have them merged with operations. And some companies, large companies like my previous workplace, fleet department was was a standalone company basically. So what we have is fleet basically serving operations and making sure that vehicles are available and in excellent condition, and also in some organizations, you also find fleet being embedded in. You also find drivers management as well being embedded in fleet management, and that's because the person, usually you have a fleet person who is extremely vast in vehicles. He had undergone a lot of trainings in terms of even the workings of the vehicle usually. So basically, this person is the person that is usually in the best position to engage with the drivers and also teach them on the workings, because they are the one that's going to be using it. So basically, I will also move into the components of fleet management. That is, so one of the key components for fleet management or fleet managers here is for acquisition and integration of vehicles. And broadly speaking, this though it appears to be a summary, it involves a lot of activities, which ranges from you know whether you want the vehicle acquisition itself, the requirement gathering, vehicle acquisition. You want to know the how you want to bring these vehicles in, and just to also mention, there are some instances where, like, you want to bring vehicles in and you are deciding what kind of options you have. Either you want to bring it as a CKD, which is complete knockdown. In this case, you have to bring the vehicle and assemble it locally. And you're also talking about SKD, which is semi-knockdown. You have to come and do it locally, but it's not fully knockdown. So you have companies like that in locally that offer this kind of services. So this is part of the fleet management function. And of course, maintenance is one of the core functions as well, which is maintenance of vehicles. And this is basically to ensure longevity of the vehicles. We go into fleet monitoring, which we'll be discussing more about. Driver management, I've mentioned earlier, include driver training, performance evaluation, safety monitoring. Regulatory compliance, this is also a basic fleet function, ensure that vehicles meet local and regulatory standards, emission standards. Bringing it back to Nigeria, we have a lot of vehicle documentations, you have permits and the rest of it. So these are just an overview of fleet functions and also trying to bring it to use case. So Internet of Things basically refers to a global network of connected devices. Currently, there are about, I think by the last research, there are over 20 billion of these devices. And the estimate is estimated that these devices will go to almost 45 billion of them. So any simple device can be turned to an Internet of Things, basically. And most of these devices are, let me just, an example would just be basically, basically Internet of Things basically refers to these devices that communicate over the internet. And what you have as well is, sorry, excuse me. So am I audible?
Yes, we can read, we can see.
Okay, so Internet of Things, like I was saying, basically refers to a global network of interconnected physical devices communicating over the internet and sharing data. So basically, we can turn any device into an Internet of Things by adding any device that can at least communicate a certain state into an Internet of Things. An example would be your refrigerator. I'm interested in knowing the temperature of the refrigerator. I can put a temperature sensor inside that refrigerator that communicates the states of that refrigerator over the internet. So wherever I am, as far as I'm connected to the internet, I can see the temperature of that refrigerator and decide whether I want to switch it off. How do you switch these kind of things off? You have also smart switches, which we also have in homes right now. So smart switches are also connected to the network, and you can switch those switch on and off over the internet. So basically, like I said again, you can turn every single device, most devices into Internet of Things as far as you're able to communicate the states. I also try to mention even your chair can also be on the internet. I can put a accelerometer on the chair that measures that can trigger if that chair has been moved. So if I move that chair and I have a sensor that is connected to an IoT device that has internet access, I can see whether that chair has been moved. So this is just trying to say that very simple machines, very simple components can be put on the internet. You understand? And Internet of Things basically will exclude things that are basically supposed to be on the internet, like your laptops. Those are not going to be considered the Internet of Things. Your laptops will not be on it. Your telephones, your PCs, those will not be considered the Internet of Things. So just an example of Internet of Things application I had mentioned, you have your home automation devices, which are your smart homes, you have your thermostats, you have your light appliances, which are all connected on the internet. For urban transport service, you have your speed cameras. Yes, for this, I would just like to also iterate. We have this currently in Nigeria now. And if you notice, people have been talking about things about third mainland, they have speed cams and stuff. And you also have your plate detect system used by Lagos State government to capture vehicles with expired documents. So those are applications of Internet and STEAM in Nigeria that the government is also utilizing to also facilitate quick capture and quick capture of people that fine, and also in some instances people say to generate revenue as well. But and you also have Internet of Things in terms of security. We have applications of Internet in security cameras, motion detectors, and the likes. In banking and finance as well, you'll be surprised that ATM in some regions they have ATM theft. Some people move ATMs. So if you equip the ATM with a level sensor, with an accelerometer, with a camera sensor, you are able to deter, these people that want to, commit this sort of crime. So these are some of the applications of Internet of Things, basically, that we have. And like I said again, in Nigeria is actually catching up, and we're expecting a significant growth because more devices are getting connected every day. Right now, you can connect any simple thing to the internet. So those are just the basic of how Internet of Things, even from chairs to as big as airplanes, all of them can be put on the internet. So here we are talking about IoT adaptation in fleet management. Like we had said earlier, remember, Internet of Things require a network communication. It requires an IoT device. It requires an IoT device with the capability to connect to the internet. Internet of Things also will require a internet gateway, which is an avenue for also featuring that data. It converts that data, it processes that data before it transmits to the cloud. It stands as a bridge basically between the IoT device getting the data and the cloud. So basically, Internet of Things has evolved, and recently we had a bit of add-ons that have been included in to aid vehicle telematics. So I'll just quickly go through some of these diagrams I've shared here. And the first diagram is talking about heavy goods vehicles and how we've been able to incorporate this in having an engine hours based service. So for this kind of vehicles, your conventional maintenance practice, some of which is based on mileage, some of which is based on time, will not work here because these vehicles they do very little distance. Like this every good vehicle used in construction industry, like the tipping trailers, they do very little mileage. You can't use time because if you run that vehicle for continuous hours for say, 16 hours for days, you won't say, your usual 3 months plan will not work. Your usual 1 year maintenance plan will not work. For this kind of vehicles, you have to rely on an IoT device that is able to capture engine hours of these vehicles. Otherwise, you're going to have very costly breakdowns. So what you have here is an IoT device connected via CAN bus, which is like a gateway through which ECU communicates. So CAN bus basically is a controller area network, and it's run on J1939 scripts. Sorry if I'm being a bit technical, which is the language that those ECUs communicate to each other. So basically, what you do here is to have a device that connects to that highway and is able to pick very, very relevant information from the vehicle through a wired connection. And we also have some other avenues of connecting, and also contactless, which will help you maintain your warranty, because some manufacturers will not want you to at least cut some wires, but there are contactless solutions for capturing this data. So once we're able to connect through this highway, through this CAN bus on the vehicle, you're able to get this very, very vital information, including engine hours, engine oil level, and some of them. So because you're able to do this, you can practically maintain these vehicles efficiently outside the conventional ways of trying to track maintenance, which is by mileage or by time. So that's one of the use cases how IoT has been used in the construction sector. So we're not talking about the next diagram basically speaks to how IoT has been used in driving safety of drivers. So in this use case, you have the driver identification tag via RFID, and you have a second level check, which is going to be a breathalyzer system that's also connected to the immobilizer and connected to the IoT device. So basically, you have to pass one, which is showing that you have access. You're an authorized user for that vehicle. RFID usually is programmed with the details of the user, maybe the driver's name, his age, and his other details. So you program that card with his information, you slash it on an RFID card reader, and it authenticates whether that driver is unauthorized. Before now, that device would have been programmed with the information of all the drivers. So once that driver slides his RFID card, is able to authenticate to say this is Idris, this is Idris. Basically, this is Idris. He identifies the person and is also able to move to the next stage, which is where you have the breathalyzer. So once you breathe into it, it's verified. It has a certain range. If it's between this range, it disables the immobilizer. If it's not within that range, it locks it down and records. Basically, the immobilizer works by is like an open circuit. So it works with a relay. So the relay is usually open. Once the mobilizer, once the device authenticates that the driver is approved to drive and has also passed the breathalyzer test, the relay will close and the connection is complete. While the connection is complete via the relay, the vehicle will start. So it does another two-stage access control. to prevent drivers under the influence of alcohol above a specific threshold to drive vehicles. So those two are some of the few implementations of IoT. I'll just give us a brief insights of how it works and why this solution was put in place. So you have an IoT analytic dashboard. Basically, this is coming from IoT data, which is a lot. Is a lot because you have sensors constantly monitoring, constantly pushing data because these data are in real time and it's pushing it over the gate through the gateway to the cloud. So you have thousands and millions of this data, and it can be very cumbersome to analyze this data. So most IoT platforms in fleets, we call them fleet management softwares. These systems are able to collect those data, analyze it in real time. So basically, all you just need to do is to just refresh. It keeps getting this data and continuously analyze this data for you to refresh. So that's just what this slide speaks to. So this is how are we enhancing fleet management with IoT. So for this, I'll be speaking to use cases, real life cases on how IoT has been engaged. So on the first one, IoT supports real-time tracking and monitoring. So basically for this, I would give us a life story. So some time ago, few years back though, we had a delivery to a client that was around the Maduguri axis. And for some reason, this is a driver that we know, the driver, delivering that goods, the driver that we know very, very well. And basically, again, this is just telling us, the real-time application, how it is useful and how IoT is able to at least help in these aspects. So this is a driver that we know very well, and based on his previous driving, behavior, we know he's well behaved and the rest of it. So around 7 p.m., this driver usually doesn't drive at night. We noticed this driver was driving at night. That was already a red flag. What is happening? We tried to reach him; it was unreachable. The vehicle was, having a lot of violations in real time, which we're able to pick. And eventually, what did we do? What we did was to mobilize the nearest police station around that axis. So they mounted a checkpoint and stopped the vehicle, only for us to establish that it was not the driver that was on that vehicle. The vehicle had been hijacked, and the driver was, tied somewhere to a tree, basically. So tracing back those the people that hijacked the vehicle, they escaped into the bush when they saw the checkpoint, and the police tracked back to where that guy was. Fortunately, he was not harmed, and he was rescued. So those are just the how that is very, very relevant. Having real time monitoring information and having to also understand when you notice something that is going wrong, especially if that driver was a driver that we know that is a constant violator, someone that breaks the rule. We might not, the person tracking then might not have picked that up, but because of the history we have with that driver, we're able to quickly intervene, and this is made possible by the real-time functionality or real-time capability of IoT-enabled vehicles. So the second is going into predictive maintenance. Again, this is going to be real life. You have a sensor that was connected to a vehicle that was, and that sensor basically picked up, so the sensor picked up via CAN bus. And because currently IoT devices, especially the telematics devices that are IoT enabled, are equipped with a lot of sensors. Some of them have accelerometers, some of them are proximity sensors. In fact, a lot of them are proximity sensors. A lot of them has smoke sensors, gyrometer sensors, all of them, they have everything embedded thanks to our colleagues from the embedded systems engineering, electrical engineering. So these devices are more or less all in one. So we're able to pick that information via CAN bus, and they noticed issue with unusual noise from the engine. That was the report it picked. And because this system basically leverages on AI and machine learning, because it's continuously observed the input from that car over a period of time. So when there are variations, it triggers it and picks it up as something unusual because over a period of time, it has observed how this vehicle should behave. And basically, it's run it through the analytical model. We have platforms that are able to do this. Some of these platforms are Geotab, some of these platforms have Fire TMS. There are a lot of them that are able to have predictive capabilities for vehicle maintenance. So based on this, the system was able to predict that this vehicle should be due in the next 1,000 kilometers. And behold, when that vehicle was brought in around that time, we found out that there was an issue with the timing belts. And this obviously has mitigated a lot of costs, which can be recovery costs because it's an operational vehicle. You're going to pay towing costs. You're going to pay a lot of, you're going to pay towing. You're going to pay costs for transloading the vehicles. You're going to pay other costs that are there apart from the reputational damage you're likely going to have if your vehicle stops in the middle of the road or has that kind of expensive repair, like a timing belt failed. So that's one of the aspect of predictive maintenance and part of the capabilities of systems that are connected to IoT devices. Enhanced safety. So for this one, I'll be going into one of the LFIs that was shared by one of the multinational companies in Nigeria in the oil and gas sector. And basically, you had a driver that slept on his truck. And over, there were a lot of near misses. And before an accident, there's going to be a lot of near misses. So eventually, the vehicle was involved in a rollover. Luckily, there was no fatality. This was caused by the dash cam. And the driver, was armed. It was not serious injury, but there was product spill. There was a lot of issues. So how are we applying this? How does IoT help safety? So basically, we're able to see and learn. And what have we done basically is to have systems or IoT systems that are able to alert driver and give them instant feedbacks. And also alerts, for this kind of thing is going to be a high risk alert. And this comes to the control room. Basically, for this kind of interventions, you usually call the drivers, and drivers basically have been trained to, when they get a call from the office, they're supposed to park in a safe place and pick up that call. So this way you're able to mitigate this kind of thing. Another way to also help, which IoT has enabled, is to have buzzers, which is able to track when things are not going on. When the driver is overspeeding, you have buzzers that will give warning signs, continuous buzzing sounds when this state continues. So you have these kind of things that are able to trigger when such issues are occurring in real time and give feedback to the drivers and also alert the managers in the office via the internet because you will know because this obviously is going to be in some remote areas and you might need a third level intervention. So this is also another application of IoT in enhancing safety of fleets. Operational efficiency. So for this case, I'll pick a scenario where we have, I'm trying to pick one of the use case for operational efficiency. Okay, so we have an issue where the drivers basically that are from a petty part of the West Ibadan specifically, for some reasons, will always park at some designated place. Maybe everybody that stayed in UI, we know there's a specific joint where people used to go and eat amala. Maybe because of that, or maybe because for some reasons they're always just staying there. So what did we do to do this? And basically the consequence of this is that there's going to be lots of OTD failure, that's on-time delivery failures, and there's going to be a lot of complaints from the clients. You're not going to meet your delivery targets. Your vehicles will be grossly underutilized, and the rest of it. So what did we do basically? What solutions was done basically was to integrate, was to leverage on some of the capabilities of the platform, the IoT software, the fleet management software that houses this IoT. And basically that's what we did was to geofence those areas and put a time restraint there. And of course, there are some logic. So I'll just go a little bit into the details. So a geofence basically is a place, is a boundary, is an electronic boundary or a virtual boundary on the map that is a point of interest basically. And what you have is a proximity sensor that the moment the vehicle is close to that boundary or within that boundary, it triggers that condition as being true. So once that condition is true, it's assumed that you are within the geofence, and it starts capturing data like time data, numbers of visit data, and other sorts of data. How many ignitions or ignitions of basically it can start capturing IoT relevant information within that geofence space. So what we did basically was to have some conditions there. So whenever drivers are there, when they exceed the distance, a period of 1 hour, it lets us know that this driver has been idle for the past 1 hour. So you get a notification, and this is made possible by IoT. Again, like I said, this is based on this proximity sensors that have been embedded on that system and the capability to also measure, leverage on GPS technology as well. So basically, we have alerts and we are able to engage that driver to stop them from excessively staying in that location. So that's one of the applications of that in terms of having operational efficiency and having to engage on time and stop excessive delays, excessive idling for drivers at specific locations. So you can use that. That is one of the use cases on how IoT is also driving operational efficiency of fleets by leveraging on those kind of stuff. There are other examples as well of that as well. So in terms of vehicle acquisition and disposal, so basically this is speaking towards, I'll just use another case. So there's specific trucks that is extremely difficult to pull data from. And basically, once you have this kind of trucks, everything has to be very, very manual, extremely difficult once again. And to be fair, the user, the OEMs as well, the manufacturer of the truck are not even ready to share some of this information. So you have vehicles like that. So basically, what basically happened is this influences decision for purchasing. So if you have a vehicle that you can't diagnose remotely, especially for people that have operational centers very, very far away and they cannot remotely access the vehicle, they can't remotely pick very, very good data, especially if you have a workshop, say in Lagos and you're operating say somewhere in the north. And basically before, of course, you have a data center, but there are some places that accessibility is very, very, very difficult. So you need, devices that are able to at least give you some information, critical engine information, vehicle performance information, that's so that you can make quick decisions and make those repairs very, very fast. And so basically that's one of the decisions that IoT influences. But in terms of vehicle disposal, so when you trend vehicle performance, again, like I said, you keep getting notifications, you have real-time data on the performance of this vehicle. So basically, once you study those trends, sometimes you will notice that in these vehicles is continuously having issues, continuously having repairs, this nature of repair over time. IoT analytics basically helps you to have that insight. So this kind of insight also lets you know when it's time for you to dispose of those kind of assets. Then we have for fuel theft mitigation. So when you look at IoT data, this is also coming from real situations. So we have situations where there are fuel thefts by the operators of the vehicles and trying to play a fast one. So how do we mitigate this? So using IoT. So usually when you trend fuel consumption with an IoT device or basically pulling data from IoT device and you trend that data on the platform, you notice it's going to be a negative sloping line downwards, because the more you consume that fuel, the more you move, the more you consume fuel. So it's going to be a negative slope line. But a gentle negative sloping line, pardon me. But once you have a fuel theft, you're going to get a steady decline. It's straight down, a vertical line at that point, vertical straight line to show you that, something had happened there with the fuel level. So we have fuel level sensors. Some of these IoT devices can pick those data via CAN bus, and it's some very, very manual, it's some very analog trucks, you are able to pick that data by using a four-level sensor. So this way, IoT is able to let you know exactly where some of this theft occurred, and you're able to visit that location to find out exactly what is happening there. And in real time, we've been able to, mitigate and find out exactly locations where theft happened, and also show this to the driver that say, no, this is what you did, and this is where you did it. So those are some of the, ways IoT has been enhancing fleet management. I don't know if at this point we have any questions before I proceed. Okay, I'll move on. Okay, this is going towards the case study of a company in Lagos that's a multinational that was looking to implement IoT solution for their fleets so that they can get a lot of insights and also better utilize their fleets. And basically, they also had a rise in hijacking cases leading to significant vehicle loss. So this is just showing us how we implement IoT for a new company that is looking to leverage the benefits, leverage IoT to also obtain some of the benefits. So the first phase basically is to gather the requirements of the clients. And this basically is what they had advertised. What they had said then was they had delayed shipment, they had poor asset utilization, and they had cases where people, go with their vehicles, they are unable to, recover these vehicles. And because they hadn't implemented IoT, they're able to get real-time visibility of the vehicles. And what do they want? They wanted a GPS-enabled tracking system with buffering capability. So buffering basically is the ability of the device to store some of those data on its memory in the event it's unable to push that information to the server. It usually happens when there is network connectivity or internet connectivity issue. And there's some places you notice this. There are some areas in Nigeria, Potiskum, a lot of places where there are black spots where you have zero visibility because there is very poor reception there. So at this point in time, so in order not to lose data, you need a device that is able to at least hold some of those data to where it's able to get to a location where it's able to push this data through the gateway to the cloud where it's not accessible. So basically, you won't lose visibility. So they also wanted cargo monitoring, delivery and performance metrics, which is a dashboard that shows how they are doing, how they're able to, how fast they deliver, do they meet their OTD, do they idle at the customer locations, those kind of information. They're also interested in knowing that. And they also wanted predictive maintenance for their fleet of vehicles and driver certification and control system. So these are some of the things they have requested. So what did the team do? So what we basically did was to conduct a root cause analysis to identify what exactly the problems were. And based on this, we're able to select the hardware that is able to select some solution providers that will be able to meet these requirements. And what we were focused on was basically the IoT device with the capabilities to connect seamlessly with the systems and the vehicles, and it's for software that is capable of collecting this information from this IoT device. So if you have a good device and you don't have a good software, you won't get the relevant information, and that's just the truth. And if you have a good software, you have a poor device that only has basic GPS capabilities, then you won't get any information. So you have to have a good match between the IoT device. In some cases, you can also have external sensors that you need to put, like your panic button, like your driver identification systems, like your temperature monitoring sensors, to go. And you have to have a system that can take that information from that IoT and, make it make sense. They also wanted driver monitoring, a foolproof driver identification system, and the ability to monitor driving pattern and behavior. So the next phase was the execution. The next phase is going towards execution. So for execution, basically refers to the deployment of these devices. And basically what we're able to do was to have devices meet these requirements. In respect to their first requirement, delayed shipments. What we had found out then was there was a bit of time wasting with the foiling. And this obviously we brought out because what we had done then was to geofence that location where the fuel is being made. And when you take that to when the vehicle actually took off, and when it delivered, you find out that a lot of significant time was wasted at the fueling station and not necessarily in transit. So those are some of the key areas we're able to find and improve on that fueling process. So sometimes you find out that it's not actually the trip that is causing those issues, but you can't find out those issues if you don't have a system that can give you that information so that you can make very, very valid and impactful decisions on that. Training and rollout. So basically, after the deployment of the solution, the drivers have to be trained, the control room staff, the logistics guys have to be trained on how to use this system, how to monitor, how to track, and how to understand what those dashboards are saying and the rest. So yeah, so pilot exercise was conducted and ensured system reliability before company rollout. So yeah, that's one of the things we had done. So before you basically roll those things out, you have to do a test before you give the client access. You have to do a test to confirm that this what you are getting indeed is true. In some cases, in some platforms, you have to do a bit of not modification, a bit of conversion. A typical example is when you have a system that is capturing in meters, and what you're interested is in kilometers. You just do a bit of division to say, okay, divided by 1,000, so this becomes kilometers. So those kind of transformations, data transformations might have to happen before once you finalize that. That's when you now roll out to the company and also start creating access for the users. And of course, at this point in time, you have to also have maybe a demo period, I think for a period of time, whereby they always come in and always ask you questions on how this is the issue. And you also have, of course, people that will lock their accounts out and be asking to fix that. So it takes a while for people to tap into it. Drivers will be very reluctant, people will be reluctant, but with time and push from the top, usually have very, very good results, exciting results. And of course, when you've done this system, you continuously optimize the system for them. You have enhancements. I remember sometimes we deployed a solution, and each time we kept on adding, okay, let's add the panic button here, let's add identification, let's connect another sensor, let's try to manage. So it's not one. You can also do some other things. You can enhance the system, you can improve it. The needs can change. So you continue evolving, and you meet those needs. And sometimes you might even have a better system that can, even give you better information. And you might not have to do an overhaul of the entire system. But, that's usually rare because most of these devices, their use case sometimes exceeding the excess of 10 years, even though they can be upgraded. But at least they have some software updates that usually push to sometimes enhance the functionalities of some of these devices. So how are we as industrial engineers, and what's the future for IoT, and how are industrial engineers very pivotal to how are industrial engineers pivotal to the future of IoT? So IoT assets is estimated to at least at about 41 billion devices are estimated to have been connected by 2025. And like I said, people add a lot of things to the internet, and those things keep gathering data. Those data are always pushed to the cloud. Your smart TV at home keeps pushing your usage data. Your washing machine is pushing data. Your smart inverter at home is pushing data. Your kettle, your everything is just pushing data. So by 2025, it's estimated about 41 billion devices that have been connected to the internet. And out of this, basically, you have a lot of advancement that has been made. And it's very, very, very key for us industrial engineers basically to stay ahead of this curve, or stay ahead of this evolving technology, and also position ourselves strategically. So one of the, like I said, there are lots of data being pushed, and from data there are a lot of patterns that can be generated, a lot of AI learning, advanced analytics tools. So basically, you have IoT devices that people are looking to get a lot of insight. People pay for data, IoT data. So what we are talking about basically is for industrial engineers to develop advanced analytics and machine learning skills to uncover actionable insights and enable data-driven decisions. So basically, if you have this kind of skill, you're always still going to be invaluable to the organization because you keep uncovering new insight. People change, new things, new trends, and you also have the, decisions to drive. Integrating IoT into processes. Industrial engineering essentials in designing and optimizing IoT-enabled workflows, ensuring that these technologies align with organization objectives and deliver measurable improvement in efficiency and productivity. So I'll just give us an example, a couple of examples. So we have an IoT-enabled workflow that is automated. So I'm interested in knowing automatically scaling my maintenance, and I want the system to do it. Like I said, technologies are evolving. So you have an IoT device that is connected to a platform. The device senses an issue with maybe your brakes. The temperature. You have a temperature sensor. Or you have a temperature sensor that is able to analyze observe the change in your braking temperature in your brake disc. So based on this, it predicts that there's a possible need for failure because there's an increase in the temperature of those brakes, and you're due for a replacement. So it communicates that change to the system. The system runs it through its algorithm and automatically schedules an inspection. And some of these can be used via, Power Automate. An example of where this has been applied is you have your violation stated, for instance, a driver is overspeeding, and that sensor, which is your GPS, you can capture speed via your GPS speed or via your CAN bus, which is measuring your actual speed from your instrument cluster. So you pick that information, then once that condition is true, say for instance, I'm saying 70, or when someone is doing 100 kilometers per hour, the moment the GPS speed, that sensor notices that has crossed 100 kilometers per hour, that condition becomes true. And the moment it's true, it triggers, that becomes an event. When that event triggers, it goes to the system. Basically, when that condition is true, it goes into your fleet manager software, which now analyzes it. The logic is hosted on the software. So the software analyzes it, confirms that condition is true, then sends an email to the respective person or the respective manager that is in charge of that vehicle or that driver. So that's one of the examples. Another very good example is on data analytics. And this one is also going to leverage on some of the Microsoft tools like your Power Automate. So you have your data, maybe you have a scheduled data, and this is where it's very, very important. So you have your scheduled data that says, calculates the numbers of, give me a report on, you have a fleet of say 600 vehicles, and you basically what happens, you have someone that downloads that report, analyzes that report. I'm talking about a large report, thousands and thousands of rows. You have somebody analyzing that report and reporting. That job can take a whole day. But instead of this, what do you do? So you have the system schedule these reports. So the system automatically runs this report, say at 12 midnight at the end of the day. When it runs that report, it sends it to an email. From the email address, from the email box, you've configured your email that emails with the information should be moved to this box. So you have a system that now moved that email from where it's going to a certain box. Then you have another flow that says, when I receive this email, launch it on. on say a Power BI, or put it in a folder where your Power BI connects to that folder and picks all available files inside there. Then based on that analytics, you're able to get insights. So this is another workflow that has been automated, right from instead of a manual person rolling a report by pressing buttons, you have the system running that report for you, sending it to you via email. From your email, instead of someone moving it and downloading it, you have an automated system that picks that information, that picks that file, put it in a specific folder that is connected to your Power BI, and your Power BI from there picks that information, analyzes it, and provides it to turns it into a dashboard and your system. So that is how you can integrate IoT into processes, into jobs that are routine, jobs that you do every day, instead of having maybe 4 or 5 people doing this. And this is how you're able to drive efficiency. People that are meant to be doing that jobs for days are able to face something else. So these are possible with some several integration of tools. You have your IoT device, you have your telematic software, you have your Power Automate software, and you have your Power BI. So all these systems, all these applications connect together to give you very, very good information. They're talking about cross-functional collaboration. So for implementation of IoT, it's very important because industrial engineers will be called in to implement some of these systems. So apart from, they have to get, very, very versatile in, doing root cause analysis. They also have to be able to manage people, manage projects, manage operations, and collaborate with people. So it's part of the skill that we have to have when you have a series of teams that they need to work together to drive this. Good example is when you are trying to integrate with your enterprise resource system. Your Navision, your Oracle Fusion, your SAPs. You can actually integrate the system with IoT, and in some cases you might need to develop a middleware that communicates, that picks the data from, because you can also have some SAPs, some enterprise resource tool that don't give you some level of access. They won't let you they won't let you write to their data tables. So if you have those kind of things, you might need to have a middleware that picks that information from the ERP, picks the information from the IoT software, or from the the software hosting the IoT devices. Then based on that, they can now, merge those information together and give you some very, very good, valuable insights. We've had some implementations of, this kind of where you have to have a middleware to, drive that communication with the team. So it's very, very important for industrial engineers to have, project management skill, team driving skill, in order to implement some of these systems. So fostering innovation and sustainability. So nowadays you have investors very, very keen on sustainability and driving, driving the ESG objectives. So most investors will be very, very keen to invest in, companies that have a ESG goal and are very, very keen, are very serious about emissions. So what we have here is you have devices, you have your emission sensors, you have a way to mitigate against carbon waste due to optimal journey management practice that reduce your journey time. And I said optimal basically because in fleet management and operations, you notice that the shortest route basically is not usually your best route. And that is because you have routes that are extremely bad, and you continuously going. They will be very short, but on the long run, you find out that you are doing a lot of repairs. So you're always looking for the optimal routes, and some of those routes you might need to visit them. You might need to visit them to ascertain their conditions, especially when it's a new project or a new client that is taking you to a new environment where you've not been to. So you might need to do a physical assessment of the road to ascertain where best your vehicles can go, depending on the kind of vehicles you are using. An example, if you have a very big truck or a cutting cider, and your client is in a street that cannot accept that kind of thing, you won't want a situation where you go and your vehicle won't be able to access the client location, and you now have to start paying additional cost or something. So IoT devices basically help us capture emission, and industrial engineers must always be on top of this to know what devices are available and how to incorporate this to meet the organization's objectives. So basically, in conclusion, IoT has revolutionized fleet management in driving efficiency, safety, sustainability, and these are true real-time tracking. And like I mentioned earlier, there are lots of use cases on how it has helped businesses to stay afloat, to remain relevant, and the benefits are timeless. It's immense. Is immense. So industrial engineers are pivotal in harnessing the pivotal potential of IoT by designing, like I said, implementing and optimizing systems that align with organization objectives. The expertise enables fleet to operate greater efficiency, enhance safety, improve sustainability, which is very, very critical in this data-driven world. So I think that is the end of my presentations. I'll welcome a lot of questions because, like I said, there are lots of use cases, and I'll be giving practical examples of how IoT can be used and the kind of solutions that can be developed. Thank you very much.
Okay. Oh, thank you very much, sir. Sorry, I was muted the other time. Thank you very much, Engineer Idris. That was an amazing lecture, and it was pretty much insightful. I mean, before we take questions, a brief sort of taking samples of how the lecture went for me. I particularly enjoyed how you were bringing in scenarios for the different aspects that you were discussing on. I mean, security, authentication, core optimization around that aspect. I mean, and how the role of an industrial engineer, particularly around the time when you spoke around mastering advanced data analytics. I mean, IoT is a major data generator right now when we look at how data is transforming the global economy, right? And as an industrial engineer, having those skills at hands, data analytics, advanced analytics, being able to make data-driven decisions. I mean, these are very important aspect of what we do as an industrial engineer. Thank you very much for that once again. That was an insightful session. I personally have some questions, but before mine, I think I would like to take from the audience. So you can just raise your hand if you have a question. I think Michael Ogusoya and went first. Please go for it, Michael. Thank you very much.
Yeah. Hello, can you hear me? Hello?
Yes, we can, Michael. Yes,
Okay,
yes,
great.
Mr. Michael.
Yeah.
Yes, sir. Thank you very much.
Thank you so much, Engineer Idris Oshodi. It was a very nice one. I was just trying to pay more attention despite the interference here. So my quick question is going to be more on the human interference. I know it's not very easy working with humans, especially having drivers have to drive trucks, all of those things. Have there been any case whereby there is an interference with the telematics device, such that you're unable to gather data? Maybe somebody tampering with the device. Any case of such, and how did you mitigate, if any? And if at all it hasn't occurred, do you plan to look into that in the future?
Okay,
I don't know
thank
if
you,
my question
Michael.
is clear.
Yes, Michael, your question is very clear. And
Okay.
again, that is one of the challenges in the aspects of IoT, especially with drivers. So I will give you real life examples again. And so basically, what I would say, you have an instance where your driver tampers with your device. So two things: your device basically has backup battery. Some devices have backup battery that can stay once you disconnect them up to 48 hours, depends on the mode. You can put them in deep sleep mode. In that kind of mode, you'll just be sending pings occasionally. So that gives you an idea. So if you put it in that kind of mode, or you have it automatically switch to that mode, it will give you pings, and also still, even if you disconnect it, you'll still be getting, good information. That's on one part. But say, for instance, you have a driver that's taking it off, and say your backup battery doesn't kick in, maybe due to it being degraded over a period of time. What will happen is what we have done to mitigate. Yes, this kind of case is real and it happens a lot. What we have done basically is to have logic that says, so first and foremost, it triggers you once that event becomes true. Say, for instance, vehicle loses, device loses power. So there's an event you have that will trigger that says out of power. Basically, it depends on how you name it. So this device is out of power. That's one. Secondly, on the platform, you will notice that, depending on the platform you are using, some platforms will give you a color code to tell you that what you are looking at is not real-time data, that there is something wrong with your system. And it's very good to be able to differentiate, because there's also an instance where, what if I shut down power from my vehicle? It might not be a disconnect. What if it was a power disconnect? So you need to now identify, whether it's a deliberate shutdown or it's a tracking device that has been circumvented, and that can be sorted with logic. So in terms of what to do to mitigate, again, like I said, have devices that have backup batteries that can at least give you specific time, even if it's 1 hour, so that once that device goes off, you get a prompt that this power disconnect or means, because those batteries, if you're using a truck, the range of devices range between 12 volts to 24 volts. So when they pull it out, it tells you that there's no battery, device on backup battery. You can set events to tell you that when this device is on backup battery, trigger me. Then when I'm on backup battery and there's motion, then you know that there's something wrong. It can be on backup battery when you shut down the main power from the truck or from the vehicle. It goes into backup battery mode because now you've got access to supply. But when there's power cut down and the vehicle is moving, then this driver is tampering. Then you can begin to call him. You can begin to call his guarantors if you have that kind of information. And when he comes back, there's a there's a consequence management waiting for him. You get. So I think those are the two instances. Again, you invest in devices that at least can give you good backup, so that that device is able to come to you live in real time that there's something wrong. Then your logic would also be able to tell you when it's on backup battery and there is motion detected. So it sends an alert. So that will help you distinguish whether it's a tampering case, because you can't have shut down the main power to your truck or to your vehicle and there's motion. You get. So you can't do that. So there are logics that you can put in place that will help you determine and filter out other cases. But of course, if you don't, there's no consequence management. You also have drivers doing the same and the same and the same. Into what we've done to what I've done or what we've done. In fact, we've gotten to the extent of putting padlocks to the dashboard to stop drivers from, going to the device. But some of them will take out your entire dashboard to say, no, I must get to this. So, but in those cases, they know that that is obviously going to be their last job. And when they come, some of them don't even come back. They'll just from there go, because they know that there's really nothing, there's no point, because they know they've been caught. So you can mitigate against that. You can know. I won't say you can stop it. You can know. And you can have valid evidence to present in court. I've been to court a few times on this kind of cases as well. Only that our judicial system is not exactly the best, and at the end of the day, you find out that you're spending money instead of prosecuting the driver. Hope that's clear, Michael.
I believe that was, I mean, that was quite interesting. That was an interesting experience. Thank you very much for that.
Yeah, thank you.
Before
Thank
Yes, thank you, Mr. Michael. Before we proceed to the next question, I'd like to invite the chairman of the day, Engineer Olajide, the CEO of EISNL, for a brief comment. I mean, after listening to that lecture from my guest speaker, just to hear one or two thoughts from the chairman of the day. Good evening once again, sir.
Good evening. Thank you, Waris. Engineer Idris
Good
Oshodi,
evening, sir.
you've done a very good job. I'm impressed. I know that Wale and the team at TSL must have felt very bad losing you. And I'm sure the guys in Sarah Energy are so glad to have you. And well done, IEs. This is the light we should keep shining everywhere we go. I'm so happy and impressed. My comments, because he has done a very good job on this, applying, talking about the practical ones, giving insights, examples. I mean, these are real issues that happen in the industry. And at the same time, he's shown his good understanding of the application of knowledge to real life situations and work. And what I would like to say to as many students who are on the platform tonight and young engineers who have just graduated, or those who are already working, those of you working as well, is to try to enlarge your horizon. Attend seminars, industry-based seminars, industry-based conferences, events, showcasing of new product lines, new devices that will widen your knowledge. And this kind of platform we have is a very good one, which we should keep. We should ensure at all costs to keep this, and probably even to enhance it better than this, because this is a resource, a very, very good platform to share ideas, to share knowledge, and to know a lot about trending things and what people are doing. I can really, really appreciate him. I mean, even for those of you in the sales and sales engineering aspects, this is something that is a line that you can, if you latch onto this, can help you to enhance your prospects in product engineering sales. Thank you very much.
Thank you very much,
Thank
sir.
you very much, Engineer Lajide, for that wonderful comment. I mean, we can all feel it already. Like, I mean, one, you can't tell me you've been here for the last 1 hour and not having picked one or two things away from what our guest speaker has spoken about, particularly around the applications of IoT in fleet management. And like our chairman just said, expanding the horizon. We can even start thinking outside of fleet management and how IoT spans across other aspects and different areas of the economy. Thank you very much for that, sir. I'll be going on to invite Professor Olufemi from the University of Pretoria, representing Professor Weinstein, for a brief comment on our guest lecturer's discussion for today. Thank you very much, sir.
I hope everyone can hear me, please.
Yes, sir, we can hear you, sir, loud and clear.
Thank you so much.
Yes, we can hear you.
Thank you, Sir Mas. I think the first thing I want to do is congratulate the presenter. This is a very, very well done job. Thank you so much. Because this was not presented just as an academic discourse. It was presented on the basis of applications and usefulness of many of these things. So thank you for the lecture today, and thank you to the organizers. But there is one thing I will need to probably raise. Maybe I should have raised it in another forum with Professor Ladokun. But it might be important to just mention it here, because I know when I was there as a student, we are probably partly constrained about what we do, how we choose our courses and specialization areas, by what the National Universities Commission, if I am correct with the name, what they want us to do. With what we've seen tonight, a suggestion I will probably want to pass down that we all stakeholders in industrial engineering at UI can start considering it, to start looking ahead. How else do we think we actually want to brand our department and our courses? Why did I say this? The future will get more and more data-driven. I remembered when I first got to the University of Pretoria, then as a staff member, and then as one of the junior lecturers when I started teaching, we had a discussion one time. If we look at what we want to teach now, we must look at where we think our students will work in 10 years' time. And that is the course we must start teaching now. If we don't do that, by the time our students are graduating, we'll play a catch-up. And next time we play a catch-up. We know we can't always teach students everything, but we want to teach them what we believe will be the most relevant things. And part of the challenge we've had is many times because in our environment in Nigeria, we consider that everything engineering has to be hard engineering or engineering. And today, software is one of the biggest part of engineering, especially even people in electronics engineering probably spend more time in programming, if you know with what they do today. And when I see what is presented today, a lot of this has to do more with systems than even manufacturing. Start including the development process for onboarding people with different solutions, from requirements analysis to solution design, and many of those things that Engineer Idris was presenting. If you don't mind, Professor Ladokun, and I know you are very pragmatic. Yeah, in fact, you are one of the most pragmatic people I've met. That maybe we need to start this engagement again. Should we start thinking of probably putting some more focus on systems and not just because industrial engineering can have focus in many areas. I know we focus a lot on industrial and production engineering, which actually is deliberate because everything we had to industrial engineering in different universities have different purposes. Maybe it's time to start considering that should we start having a lot more focus on systems. And I know a number of industrial engineering schools all over the world are beginning to consider this very, very seriously, especially with continual development of things in IoT like we have now, like many other evolutions we've had that lean more towards data systems than core manufacturing. And a lot of industrial engineering is moving towards that. Even in production systems, many schools are beginning to move towards servitization of goods because a lot more value is created and the industry is usually bigger now in the service industries. So if you don't mind, Prof. Oladokun, I would just want to say it, that maybe it's time for us to sit down and begin to engage again in the department. It might help us to look into our future a lot more. So thank you so much for this presentation, but I'm just seeing more relevance of this adaptation as I listen to the presenter again. Thank you so much, and thank you for having me again. I hope I've not spoken beyond I'm expected to.
Thank you, sir.
Not at all, sir. Thank you very much, Professor Lufemi. That was quite intriguing, right? I don't know if the HOD, Professor Ladokun, has a couple of comments on Professor Lufemi's suggestions before we proceed.
Yeah, we will continue to think and to engage and to look forward to the future. Yeah. Interestingly, Professor Olufemi is one of our biggest advisors in the department. He's also a member of the curriculum stakeholder. So we'll think along that line.
Thank you very much, sir. Professor Oladokun, that's HOD at the Department of Industrial and Production Engineering, Faculty of Technology, University of Ibadan. And lastly, before we go back to the question and answer section, I will be calling on Professor J.O. Akintayo to just hear a couple of comments from him based on the discussion that we just got from our guest speaker. Professor Akintayo, sir, thank you very much. I think Professor Akintaye is still with us. Hello, sir. Are you still there? Okay. Maybe pending when we have Professor Akintaye back. Mr. Isaac, you have your hand up. Can you please unmute and ask your question? Thank you.
Hi, good evening. I'm sure everybody can hear me. Thank you.
Loud and clear.
All right. Thank you, Engineer Oshodi, for this presentation. When I saw the poster, I was very interested because this is something that I think for personally
Mr.
for
Isaac, we're a bit struggling to hear you. If you could help me increase your
okay,
voice.
okay, can you hear me more now?
Yes, better, much better. Thank you, sir.
Okay. So I was saying, I was thanking the engineer that made the presentation to us. Sorry, Engineer Oshodi. I really appreciate this presentation. And when I saw this on the platform on LinkedIn, I was really excited because this is one of the things I think is needed. In fact, some of the clients that I know, this is some of the things I feel like may solve their problem. Having said that, I want to say good to hear from you after a very long time. We've worked together before in Transport Services Limited, and the questions I want to ask, I think they are practical. You can relate to them because those are the things that I think I'm very, very interested about, and I will use that to relate that with clients that may be interested in this solution. Now, I'm coming from the angle of predictive maintenance, preventive maintenance, and root cause analysis, using this as application. And why I'm saying that is, when I was in Nigeria as a fleet person, as a fleet maintenance manager, right, I noticed that this kind of solutions are very, very good if the trucks are new or if the trucks are well maintained. When I get to the UK, when the fleets and the trucks are very, very good and they are well maintained, all these things are very easy. You can easily track anything that you want to track, something like that. But in Nigeria, with the conditions of the trucks that are on the road, I've seen many trucks. And I know that Engineer Oshodi can relate with this perfectly. You understand? Incorporating, tracking, uh, maybe when a vehicle needs to come back to the workshop for brake disc repair, clutch replacement, and something like that. There are some trucks. There are some trucks I feel like installing something like this may have some limitations because some of them don't even have the required sensors anymore, something like that. So, how do you think that this solution you can use this solution uh, for for all these should I say old trucks or trucks that are not well maintained in Nigeria, in which the client suddenly decide that I want to use this solution to solve my problem. In the area of tracing, maybe breakdown root cause analysis, one, predictive maintenance and preventive maintenance. I think you can relate to what I'm trying to ask you because I think you know the angle I'm coming from based on our experiences together. Thank you very much.
Thank you, Isaac. Thank you for the question. So, like I said in earlier, you cannot, you need to know your client's requirements. And it's like saying, um, I want to, I want to get engine diagnostics on a vehicle that doesn't have an ECU. You understand? So the best you can do, you can't pick your CAN bus data from that kind of vehicle or a vehicle that is extremely analog. You can't get some data. So if he's talking about I'm just trying to find a good use case. Say you have a vehicle that the speed sensors have been pulled out. You know, like we have in some of the cases. The next best thing you can use is to rely on your GPS speed because that's the only thing that can. So if you have a client that is telling you, I want you to get actual speed from this car. I don't want to rely on GPS speed because of the disparities or because of the fluctuations that usually happen once in a while. And you don't have an ECU, you don't have a working this thing. It's true. You can create the vehicle. So what you just need to do is to tell them this is what you can get with this type of vehicle. In terms of, so you look at the available sensors, we have your pressure sensors that can be incorporated with IoT. So you're not going to be picking this kind of information directly from the ECU. The ones you can pick manually, fantastic. You can reckon on the available sensors because like your temperature, you have over a period of time, you have the temperature when this vehicle was working normal or the kind of vibration this vehicle was making. You get so you can get something close, maybe not perfect, but something close. So you have those kind of sensors. I think you have your pressure sensors, you have your level sensors, your gyrometers that can actually help you, at least get some level of insights or information on what you want to do of at least the behavior of the vehicle because what is actual should be coming from the electronic control unit. But that means you have to go analog. It's just like when you have someone requesting for fuel information and you can't get it through CAN bus, you get a fuel level sensor that you put in the fuel tank. I'm not really an advisor of that, but that is really the only solution if the client is insisting. So I would advise is you look at the capability of that vehicle, what's are working, and how best you can at least get something near. So I think that's what I would say because I know some of those vehicles we see on the road, and some of them you would be asking too far. To say you want to get some kind of information from it, like say you want to get the cylinder information, cylinder misfire, the spark plugs information. You can't get that one. But what you can do is something close to say how does this vehicle behave when everything is normal? How does this engine behave when everything is, when there's an issue? So once there's a variation in that behavior, then you can begin to get information that calls you to at least call the vehicle in for an inspection or some sort. Hope that highlights it, Isaac.
Yes, thank you, Oshodi. That's perfect. Thank you.
Okay, thank you very much, Engineer Idris Oshodi, for taking that. I know we're a bit behind schedule. Please bear with us, our guest speaker and everyone in the audience. So in a couple of minutes, we'll be rounding up the session. So I would like to take the one last comment or goodwill message from one of our guests of honor, Professor J.O. Akintayo. Earlier on, I called him, but he was not. I think he couldn't reach us then. So, Professor Akintayo, sir. We can't seem to hear you yet, sir, but you're on mute.
Learning new things and new.
Hello, sir. We're losing you, sir. I'm guessing Prof is having some network issues.
I'm speaking from here, and I think
we can hear you
I'm
now,
not
sir.
muted.
We can hear you now, sir.
Thank you very much.
Yes, sir.
I'm saying that it's been an exciting evening, learning, new ways of doing things, and which has underscored the significance of industrial engineering and to the scheme of things. I just want to use this opportunity to pay tributes to the founding fathers of the department, Professor Sifo, Professor Chasawaba, Professor Oluleye, Professor Akambi, and many others who have labored tremendously to bring the department to what it is. And our living legends like Professor Ladokun and Dr. Kolapse and others. So, as I said at the beginning, that learning is a lifelong process, and also that our commitment and attachment to our department is also a lifelong one. I want to encourage us to bring others on board. What you have learned today, if you are to pay for it, we are going to pay a fortune. But Engineer Idris Oshodi has guided us, from life experience, even on how we can do things better. So I extend my best wishes to the department and also the Alumni Association. And I want to thank you for this opportunity you have given me to be part of this unique and important occasion. Thank you very much, and God bless.
Thank you very much, Professor Akin Ayo. It was really nice having you with us here this evening, sir. And to all our special guests of honor and our chairman of the day, we are very, very grateful to have you amongst us tonight. Within the next 5 minutes, we'll be rounding up. I think we have one brief question here, just one last question from the audience that says, how do we curb drivers' behavior, safety during travels, track engine performance, and vehicle security using IoT? Because many companies rely on IVMS, which have all these features, instead of complete digitization using IoT tracking devices. I don't know if Engineer Oshodi got that.
Okay, so how I would answer that question? So your IVMS, which is your in-vehicle monitoring system, is also an IoT device, basically.
Right.
And that device basically helps put your vehicle on the internet to become an internet of things. So in respect to, how you curb that, it's a bit of using that to using what you have to optimize. I can speak towards, how you want to do that, how you want to use that, because IVMS basically is, in fact, is more or less, and like I said, is an IoT device that speaks towards fleet management. So, boy, let me just go down through what you've said in terms of driver behavior and just pick a bit of hints on there. So, drivers' behavior, like I will say again, there has to be a bit of consequence management. Otherwise, there's really nothing you want to do, because if people keep flaunting and there's no consequence, and it has to be very strict to be a deterrent. And so for me, in terms of their behavior, you can't change anybody. It's not everybody that has to work for you. So if the driver doesn't fit your culture, it's not a culture fit, or some drivers that believe that I have to take something from the company, then those kind of drivers, you have to let them go. But what you can do is to at least give them a safety platform. You do your proper journey management for your operation. The drivers see that you care. You have a good welfare package for them. But irrespective, even you have big companies like the DHL that, at least to some extent, their drivers are okay. You still have this kind of behaviors. So there's in terms of driver behavior, there's really nothing you can do apart from just do your best, and know that not everyone is going to be your culture fit. So that's just what I have to say with respect to that. Thank you.
Thank you very much, Engineer Idris. I think that speaks to the question on the human interference that was asked earlier on as well. So thank you very much for answering that. I think we'll be having our last question for the evening from Mr. Stanley. Please, if we can make it very brief because of time. We're a bit behind time. Please go ahead, Mr. Stanley.
Okay. Good evening, all. Good evening, Mr. Idris, for this session. I really appreciate it. So, straight to the point. When it comes to during your presentation, there's a part where you mentioned about network interference and the rest. Can you hear me?
Yes, sir.
Hello. Okay. So there was a part of the presentation where you're speaking about the network interference and when you're out of coverage. So now that brings about the question I'm about to ask now, which is IoT devices. I'm pretty sure they don't consume much data. Once it comes to the data plans on connecting these devices to the internet, how are you able to curb the fact that you're not meant to even subscribe even 100 MB data should be able to last for over a month. And since you are sending this data in bytes, if I'm not mistaken, you get. So how do you manage to do data management in that section?
Okay. Some part of your statement was broken, but I hope the one I heard, I'll be able to make sense of it. Okay, so data for an IoB device, give or take, you have like 10 MB, 15 MB on a monthly basis, even with full activity. And I think with the NCC directive that you have to have registered SIM, there's a limit to the numbers of SIM you can register. So in terms of IoT, so what most companies would do is to have a bucket plan with their telcos, where you have a bucket of SIMs pulling data from a single bucket. So you have, say, 500 trucks. You subscribe to a 4 gig data every month. Each of those SIMs pull data from it. It will still be, very sufficient. Even if you have, well, unless you are going to be using a camera, like a ROV camera to be streaming. So your data will definitely not be like 10 megabytes. So in order to manage that, you need to have, I think what MCC has said, you need to come and register as a business. And what usually happens, they have dedicated IP addresses for, I think it's IoT.m2m for MTN, at least that I know for MTN. So you have to have a dedicated access point so that, and some limitations. So there's a way to do it, but you have to register as a business in terms of data subscriptions to these devices. But as an individual, you won't be able to do that. You have to register or have a company that's subscribed, and you have maybe like a rental, of some sort. I don't know if that speaks to what you're talking about, Stanley.
Mr. Stanley, are you there?
Yes, very much. I really appreciate that.
All right, thanks.
Okay. Thank you very much. To our audience and to the guest speaker and our guest of honors, thank you very much for being with us from when we started over an hour ago up to this moment. Rounding up, we'll just take a final remark, sort of, or let me say conclusion from our guest lecturer of today. I mean, just to wrap it all up, then we have a vote of thanks from one of our alumni who is also a key aspect of the IPA alumni series. Thank you very much.
Okay, Waris, thank you very much. So for me, it's something that telematics, fleets is something that has always been very super interested to me. And most times, even even when I've been told I'm supposed to be in the office, I rather just go out there to the field at least to do it. So it's fun for me, and having to present it to people and my superiors, my lecturers is it's an honor. And have very, very fond memories of the department, everybody, right from my Mr. Professor Ladokun to Professor Akombi. I have very, very, very fond memories of everybody, and I'm grateful to have been called upon to give this lecture. And what I would also say to my IEs, fellow IEs, is that irrespective of where you find yourself, you find out that the things you've learned, maybe not direct, are always applicable to the real life industry. So, for instance, somebody would ask, how is quality control, how is it applicable in fleet operation, in logistics? I say quality control. So you have 100 drivers going to say from Lagos to Ibadan. Someone decides to pass through. Apologies to people that are not from Nigeria. So you have someone trying to pass through Shagamu interchange to connect Ibadan. You have someone going all through straight to Ibadan. You have someone passing through Abeokuta again, through Songo Mowe to connect, Abeokuta. So you can't have a quality trip like that. So what are people done to do that? They have a journey plan that specifically tries to adapt or try to restrict the movement of drivers to a particular place so that they can almost have very similar outcomes, apart from the fact that, all external factors like traffic that might, but at least you are sure that 100 out of, out of 100 trips, you have almost 90 something, almost, threshold. That is quality of trips. So again, wherever we find ourselves, there are always implementation of what we've learned our undergraduate days, which was when I was in UI, and it's been an extreme honor for me, coming here this night. Thank you very much.
Yes. Thank you very much, Engineer Idris. I mean, it has been a privilege for us, myself, and the audience, I believe, as well, learning from your wealth of knowledge. It has been a really, really insightful evening, and I think I've enjoyed myself. It has been enlightening, and it has been fun as well hearing from you. I mean, I loved the applications. It was really, really intriguing for me. So I know we're a bit stretched, just a couple more minutes. I'll be calling upon Engineer Oluwaseun Okpadari, who is one of the key organizers of the IPA Alumni Lecture Series, to give us the vote of thanks for this edition of the IPA Alumni Series. Engineer Okpadari, please, good evening, sir.
Yes, good evening, everyone. I hope you can audible enough. The chairman,
Loud and clear, sir.
Ajibola Olajide, our special guest of honor, Professor Stein, ably represented by Professor Olufemi Adetunji, our guest of honor, Professor J.O. Akintayo, our guest speaker, Engineer Idris Oshodi, for that. Thank you for that wonderful lecture. Our moderator, Engineer Waris, the HOD, Professor Victor Oladokun, our fathers in the house, the past HODs, our dear friends from other departments that have joined this 27th Alumni Lecture Series tonight, our dear alumni members and our dear students. It's an honor to be giving the vote of thanks at the 27th Alumni Lecture tonight, which also rounds up the Alumni Lecture Series for this year, 2024. We want to sincerely thank you for being part of this discourse throughout this year and since inception. And I believe that you have learned a lot this year. And one thing for me is not just what we've learned from the different speakers that has graced this platform, but the opportunity for us to see into what is happening into other industries that we may never be privileged to have worked in, and to also know the opportunities there that we can also leverage in terms of investment, business opportunities and all that. And I believe it's the same thing for you. On that note, on behalf of the engagement team, we want to say thank you to everyone who has been a part of this journey in this year. Thank you for being there. Thank you for coming. And thank you for always staying true to the end of the lecture series. It's our hope that you will be part of our journey in the coming year, 2025. On that note, on behalf of the engagement team, once again, we want to say thank you for your support. And we wish you a Merry Christmas and a prosperous New Year. Thank you and good night.
Thank you very much, Engineer Okpadari, for that. Before we start leaving, thank you very much, everyone. From the chairman of the day, the Engineer Ajibola Olajide, who has been with us since we started the session. Thank you very much for joining us this evening, sir. We really appreciate your presence and your words of encouragement. It has been an honor and privilege sharing this space with you this evening. Professor Stein, ably represented by Professor Olufemi, Professor Kintayo, the HOD, Professor Ladokun, our father in the department, Dr. Kola Wale, and every other person within the audience. I see Professor David Fadari as well. I see the CEO of Phylum Integrated Services Limited. Most of our alumnus, alumni member on the platform tonight. It has really, really been a wonderful evening. An evening of learning and entertainment. And for me, it was entertaining, right? It was entertaining because, like I said, the applications were intriguing. Right. There was a time I was in a car, I was traveling, and that car, we were late, and it was around 12 a.m. And the driver had to stop, right? And I was like, why are you stopping?
I mean, we need to get to our destination time. It was like the car needs to be stopped at this point in time because there's a notification system that says the car can only move every 4 hours. So after 4 hours, the car has to stop for 30 minutes, then maybe feed data back to the control system. And hearing what Engineer Idris has explained today around fleet management, I mean, all of this makes sense now. Yes, I understand it was IoT, but I mean, how it all comes together. Like Engineer Okpadare said, this is an avenue for us to learn in a space that we might never have the opportunity to work in. I mean, the global economy is diverse enough. We can only pick bits and bits and bits from platforms and spaces like the IPA alumni series. Thank you very much once again, everyone, for joining us tonight. So, like Engineer Padare said, this will be the last edition of the IPA alumni series for the year 2024. And for the year 2025, the first and next edition will come up on the 10th of January 2025, which will be anchored by Engineer Charles Arawo. I'm sure and certain that more information about this will be dispelled and shared on the IPA alumni WhatsApp chat. Thank you very much, and Merry Christmas, and have a prosperous New Year as well. Good night, everyone.
Thank you. Merry Christmas, everyone. Bye.
Thank you.
Thank you.
Thank you very much.
Thank you, everyone.
Thank you.
Good night. Good night. Thank you.
Thank you.
Thank you. Bye-bye. Good night.
Okay, good night, everybody.
God bless you.
Good night, everybody. Good night.
Thank you.
Are you watching? Dr. Kolawole.
Thank you.
Manhattan prosecutors are saying that Donald Trump's history of what they term malicious conduct is so serious that his hush money case cannot simply be vacated at this point, no matter how much Donald Trump and his legal team are pushing for it. So we don't have a lot of time for any development in these cases, just 6 weeks until Donald Trump is inaugurated. But during that time, Trump has once again demanded that Judge Juan Merchan dismiss the hush money case, making it now his third time that he's tried